Today I have for you a Crescent Design hydraulic burst and leak tester, or HBLT. So if you were to search for this on the Bay or something like that, you'd find it as an HBLT. And what does this do? This is mostly designed to test things like catheters to see if they burst. Stuff that's quite compliant. It can accept some changes in pressure and swell like a balloon, but if it goes too far, it pops. So you wouldn't want a catheter like an angioplasty catheter that's jammed into your blood vessels to expand and then burst when it's inside you, right? So this is a machine that somebody in San Diego area designed in the mid to late 90s, I think early to mid 90s. And and this company, Crescent Design, would design special things. And I understand this really well. They got really good at this one thing somebody asked them to do, and they decided they would build a custom machine for that, probably for that one company, and decided to productize it into, why not? I mean, leverage the design that you've got and see what you can do from there. I've already taken the lid off. In fact, this one had I have two of these, and this one, when we use them at my work, and this one had a bad not VFD, compact fluorescent. I'm not even getting that right. CCFL, cold cathode fluorescent lamp inside it. So I did take apart the display and repair the lamp in there. You can see the eerie green glow back here as the backside of the lamp shines through the FR4 PCB. Oops, the FR4 PCB right there. We'll do that in post. As you probably know, I do not edit a lot of these videos. So here's the inside. The control is here, and I believe it's built off, a Motorola 68,000 series. Couple of EEPROMs back there. There's actually a couple of GALs, two lattice GALs down there, which are also programmed. This is an early firmware version, version 1.34. They're up to like 2018. 2018 is their latest version. And this is from circa 1993, 1996, something like that. Big toroidal core transformer here. This is well before the days of super awesome switch mode power supplies. So they wanted all sorts of power out of this thing, and they put a toroidal core transformer. They didn't use an like an open frame supply. They decided to build their own. They rolled their own, and you can see some heavy filter caps. If I can find a date on there, I'll gladly give it to you. I don't know that I will. But yeah, there's quite a bit of regulation down here. And there's a fan, which must be thermostatically controlled, I think, because it's not on right now. And that is on the... they won't be MOSFETs. I can pretty much guarantee you that. They'll be on the either transistors or something similar to that to control the motor. So before I get into too much with that stuff, let's talk about how it actually works. The thing that I just knocked off the table is a big bottle, and that's the supply water that comes in here. So we bring in some nicely filtered water here, and that goes through a filter again here, runs through this tube, up into this valve right here, and it's a high pressure. The valve is from KIP, so it's a high pressure. Let's get it focused if we can. For those of you who care a lot about what kind of valve it really is, that is a KIP 24 volt valve. So it's going to bring that in and then close off right here. If you notice, it's a three-way valve. There's also another way that this can go out, and that is up through here. There's a little pigtail here, oinky oink, to make up for some space if you need it. And then there's this dude, which is a large canister looking thing, and it says on it, Cetra. Cetra would be the weighing people, the scale people, Cetra scales, or at least they used to be. I have not looked to see if they're still around and still independent, but they are or were a scale company. And this is a pressure transducer. It's basically a strain gauge system, which Cetra must be experts in. And it's a strain gauge. And we can see the wire comes over here and goes up to the board. That also goes, of course, through a T, comes out here. All the swage lock fittings, by the way, all the high pressure stuff after the kip valve. Swage lock fittings, nicely done. Swage lock stuff here, I would guess it's custom bent swage lock tubing over here. And that one just goes straight out to this bulkhead fitting, which goes over here. And I've adapted this for a lure fitting. So a lot of times we're not running at, this is up to 1,000 PSI, and we're not really running at 1,000 PSI a lot. So I just put a lure fitting on here. That's that medical taper fitting that you would find on a syringe. And I put a lure fitting on here so you can attach devices really quickly and easily to it. So then let's look at the mechanics a bit. Here we have a DC motor. We can see one power wire here and one power wire down here, black and red. And we have a US digital encoder. It's a copy of the old, actually I've got one right here. It's a copy of this one right here on this McMesson force system. Here's the original HP or Agilent. It's HP was the original version. The HEDS 9100, super popular back in like the 80s, 90s. This rotary encoder is a 2-channel encoder, I believe, 2-channel. This one I'd better clean up because it's getting dirty. And US Digital knocked that off. They copied it when HP discontinued it. So this is pin compatible. And you can even see this back piece is going to be this, well, it's underneath there, but the back little wires are the same. It's basically exactly the same hole pattern, everything. Kudos to US Digital. I think that really got them going. But that goes in, and I got way off topic. This is the DC motor. It's got an encoder feedback to it, and then it goes out here to this some sort of gear system, and then we have this what looks like a hydraulic cylinder. And what this is, it's an electric hydraulic cylinder. No hydraulics whatsoever. It simulates a hydraulic cylinder. This rod goes in and out. These are limit switches. They're made by Bimba. They would normally get stuck on the outside diameter of a Bimba air cylinder, but they're being used here. They're magnetic sensors. They're being used here to see where this position rod is. So when the rod is all the way back, we'll see that sensor tripped, and when it's all the way forward, we'll see this one tripped. There's a LED in here right above my finger, and there's one on this sensor too, so we'll see those go on. Goes through this pivot arm. I did not bother to measure it, but it looks roughly like 1/3 to 2/3, and then it drives this cylinder that we looked at a little bit earlier. This is a double acting cylinder. There's a port down here too, but we're not using that one. This is only the only port we're using. So when this arm, when the actuator pulls in, it's going to pull out the cylinder, and it's going to drive this back and dispense from here. When this extends, it's going to drive the cylinder in like this, which is going to suck in liquid from here. So on the suction side, we're going to draw in from this tube. And then when we go this way, it's going to dispense. There's a piston in here, and it's going to pull forward, which is going to reduce the volume in the front half of this cylinder. Reducing the volume means we're going to eject the liquid. This valve will switch, and it'll come out here. So the beauty of this thing is really in its firmware, which I have to say is beautifully executed even at this point for the 1990s. So if we go to the main menu here, let's just show it running a little bit. We'll purge the tester. That's the easiest way to make it run. Plenty of help here to put some distilled water in it, and that you've got a syringe ready, and that you've got the pressure outlet, which is here. You've got that open. So let's do a continuous purge, and we'll see. You probably don't hear the high-pitched noise, but there's definitely the switching frequency by which this motor is controlled is pretty low, so it's audible even to me with my old ears. So this is now retracting, and this is extending, and it's going to retract until that LED comes on, which won't be too long from now. Here's both LEDs. And it won't come on for long. There it is. And now it's extending, which means this is in the aspiration or intake phase. So it would be drawing liquid in from here, from this filter area, up through this tube. And you can maybe see little bubbles shooting up there. So that's drawing in liquid. And now this one will go on. The motor reverses and we again dispense. Now we're dispensing out here, and if I put my thumb over this, if I hold it long enough, I'll probably get an error saying that it's excessive pressure. Because remember, they did say it was supposed to be open right now. So let's see if that's... Well, it wasn't too much pressure. Let's try it one more time. And it burped out this intake fitting. So because I had some pressure in there, when the valve up there switched, it kind of burped out some liquid. So I'm going to hold my thumb over it again. Okay, so now we're going to be building pressure. And I should be able to get an error on this saying that it was excessive. Nope, but it did burp. All right. So that's the basics of how this works. If you're interested, I would be very happy to show you how you run an actual test. We can burst something and see what happens on the report when it bursts. I hope you enjoyed this initial video on the Crescent Design HBLT Model 1000. If you have any questions, please do put them in the comments. Otherwise, I'll hope to see you on the next video.